Let's do the last example of distribution of sample proportion. In this example, we have this situation. According to the Center of Disease Control and Prevention, 18.8% of school-age children aged 6 to 11 years were overweight in 2004. 18% is a high percentage for children. Two questions. In a random sample of 90 school-age children, aged 6 to 11 years, what is the probability that at least 19% are overweight? Question 2. Suppose a random sample of 90 school-age children, aged between 6 and 11 years, results in 24 or more overweight children. What may you conclude? Okay, that is interesting. In this study, our sample is 90. We need to verify if with this sample we can use normal distribution. When we verify that NPQ is greater than 10 and also 90 children is less than 5% of the total children in the United States, we can use normal distribution. Then we can state that the distribution of all possible samples proportion taken from this population of children in the United States, the sample size will be 90. All possible sample proportion, if we organize this sample proportion in this number line, we are going to construct a pile like this. It's a normally distributed. And here, exactly in this point, in the center, we have all sample size 90, such that the sample proportion for all this will be equal to this value. Actually, here we have the mean of all sample proportion will be 18.8%. What is the first question? In a random sample of 98 school children, what is the probability that at least 90% are overweight? Here we have, listen, we have under this curve, we have all sample size 90, and we can read its corresponding proportion in this number line. 19 could be a little close to the center. The center of the distribution is the true parameter, the population proportion. What is the probability? 19 is very close. Then we need to find the probability that the proportion of all sample such that the proportion is 90% or more, because here the problem is asking for at least 90%. That is the first question. Then the second question is very similar, but let's start with the first question. What is the probability that if we take a sample of size 90, the proportion in this sample is 90% or more, given that the population have this proportion? And the second question is, suppose that you randomly selected a sample of 90 school-age children. From these 90, 24 children were overweight. Wow, this percentage is bigger. Then what may you conclude, given that 18% of all children in the United States are overweight? What is the probability if we take a random sample, 90, the proportion in this sample is greater than 24 out of 90. Actually, the proportion in part B, the sample proportion is 24 out of 90. What is the probability to get one sample with this proportion or one proportion bigger than this? Result in 24 or more overweight children. The question in part B could be denoted using mathematical symbols in this way. What is the probability that we select one sample size 90 such that this sample have a proportion greater or equal to 24 out of 90? Two simple questions. The first step is transform this question using mathematical symbols like this. Okay, let's do the first question. That is the distribution for all samples proportion, size 90, remember. Then we know that the population have 18.8%. Then this parameter should be the center of this distribution, should be the center. And you see the center is approximately here. This is 20%, this is 15%, this is 20, 18% is approximately in this place. Then the standard deviation of this distribution depends on my sample size, remember, and also depend on population proportion. Okay, in this case, the population proportion is 18%, Q is the complement, and N is 90. Then the standard deviation of this distribution is this value, 0.04118, okay? Also, we need to verify if we can use a normal distribution. We need to verify if my sample size is big enough, NPQ greater than 10, and we need to verify that is smaller my sample than 5% of the population. Then given that, we can use a normal distribution. And my question is this: I need to find this value in my graph, 19%. 19% is located close to the center, very close to the center, and we want to obtain the probability that a sample have this percentage or bigger. Actually, this is our problem. Remember, 19% is located there. How can we do this problem using formulas and table? First of all, remember, tables works only with z-score. We need to transform 19 in z-score. How can we find the z-score of 19? Then we need to subtract from 19 the center, what is the difference between the distance from 19 to the center, and divided by the standard deviation of this distribution. Then the z-score for 19% is 0.0458. We need to round because table works maximum with 2 decimals for z-scores. Then we need to round the second decimal. The second decimal, we need to round it 0.05. Then the probability that one sample have percentage greater than 19 is equivalent to find the probability that the z-score in a standard normal distribution, the z-score is greater than 0.05, close to the center. Then to use table, we need to find this z-score in my table. The first decimal 0 is in this column and the second decimal is in this row. Then in the intersection of this column and this row, we have this number. And what does this number represent? Remember, percentile. 0.05 standard deviation. Z-score is here. The percentile is the area to the left. Then 0.51 is this area, 0.51. Then to obtain the probability that is greater than 0.05, we need to find the red area. The table gives me the white area to the left, but the problem is asking for the red area. We can obtain this red area subtracting the value given in the table from 1. And this area is 48%. Then 48% of all samples, a size 90. When we take all possible samples, 48%, the sample proportion will be greater than 19. Greater than 19. Remember the population, we know the population is 18.8, okay? That is the solution. I told you we need to verify at the beginning of the problem. That is the formal way to show your work. First, verify that the sample is less than 5%, verify that NPQ is greater than 10, in this case it's 13.7. Then we can use the normal distribution to study this problem. The mean of the distribution will be the parameter, 18.8, and the standard deviation will be this value. We need to find the z-score, and the probability that the z-score is greater than 0.05 is 48%. Let's do the Part B. Part B, remember, what happens if we obtain one sample, and in this sample, 24 children out of 90 are overweight. Wow. Then we know that the distribution of all p hat follow a normal distribution, and the center of the distribution is the true parameter, is the center of the distribution, and the standard deviation is given by this formula. What is the probability that we obtain this value? Actually, this value is 26%. 26% is approximately located here, approximately here. Then the probability that we obtain a sample with a proportion of overweight is 26% or greater is this probability, is this area. How can we find this probability using table? First, we need to find the z-score. The z-score of this quantity is this value. That is the z-score. How far away is 0.26 from the parameter divided by the standard deviation? That is the z-score. The z-score of this quantity actually is 1.91. Then, to find this probability in the standard normal distribution, we need to go to the positive z-score table. We need to find 1.9 in this column and the second decimal in the upper row, 0.1. Then in the intersection, we have this number. What does this number represent? The white area under this curve is the area to the left, the area to the left. This area to the left is 0.9719. To find the area, the red area, which is the area that the problem is asking for, we need to subtract this value from 1. Then this result, and this area is 0.97, then this area is approximately 3%. Then 3% of all samples have 24 children. Remember, all samples have size 90. 24 children or more children overweight. That is the distribution of all samples proportion when my sample size is 90 and when this population proportion is 18%. Then that is the formal way to show your work. Then we need to find the proportion that is given. We need to find the Z-score of this proportion, and we need to find the probability that is greater than this. And actually, that is my conclusion. Listen, the conclusion is this. We only expect 3% of all samples with this percentage. The percentage of children overweight is 27 or more. 27 are exactly here, is 26.6%. Here we have all samples such that the proportion in all of these samples is 27%. But in the red area, we have all samples such that the proportion of overweight is greater than 27%. And this actually is unusual. 3%. Suppose that you have 100 balls and you have 97 white and 3 red, and you randomly select one ball. Obvious, the chance to select one white is higher, 97% of the cases. The chance of select one red ball is very small because it's 3%. It is the same situation. If you randomly select from this population one sample, 90 children, and the proportion in these 90 children is 27%, given that the proportion in the population is 18% of overweight, but in this sample is 27, then this probability is very small. Then that is unusual. Anything that is smaller than 5% is unusual. This unusual result could be explained in 3 different ways. The first one is that we actually selected one sample from the red area. It is similar to the case when we select from a bag of 100 balls, one of the 3 red balls. The second possibility could be the population, the percentage of overweight children is 18%. We were expecting in my sample this percentage, 80% of overweight children, not 27%. It's possible that we make some mistake in our study. And the third explanation could be this. The 18% of overweight children was obtained from previous study that could be done several years ago. And right now, it's possible that the percentage of overweight children has increased to a bigger percentage. For that reason, when we select a random sample, we obtain that quantity, 24 children out of 90 children. That is a bigger percentage than the previous result.